Hello, everyone. I'm going to present my project on multi-document summarization. The goal of this project is to create a summary from a set of articles, which is both comprehensive and concise. In this presentation, I'm going to talk about the two summarization methods, then discuss one technique for each method which are used in this project. And finally, I'll talk about the evaluation methods and the results. There are two approaches for the text summarization. One is the extractive summarization and the other is the abstractive summarization. Extractive summarization methods summarize the documents by selecting a subset of words or sentences that are most relevant to the context. And these methods score the important sentences and pick the top scored sentences to form a summary. Abstractive summarization, on the other hand, choose words based on the context of the document. And these words may not be necessarily from the source documents itself. And these methods analyze the document using NLP techniques, and which generate a summary that provides the important information of the original source documents. The first method is the maximal marginal relevance, or the MMR, which is a query-based summarization technique. And this is an extractive method, so the sentences will be ranked and picked from the top scored sentences. And this method aims to reduce the redundancy of the summary, while at the same time produce results which are relevant to the query. And this method uses the linear combination of relevance and novelty to get the marginal relevance. So in this equation, as you can see, the first term refers to the relevance of a document DI with respect to a query Q. And the second term refers to the similarity between the current document with the previously selected documents DJ. And the factor lambda balances between these two terms and has a value between 0 and 1. And the similarities in this equation can be, any two similarities which can be compared, which can be used to compare two vectors. And I've used cosine similarity for both these similarities in the project. For the MMR method, I've initially combined all the input documents to form a single document. All the punctuations are removed and the text is converted to the lowercase. And I've also removed all the stop words as they don't add any significance. The stop words can be like the, what, a, and, etc. And the final step in the preprocessing is the stemming, which converts each word to their stems. So for example, the words helping and helped are converted to help. And as this is an extractive summarization method, so I've also preserved the original sentences, which will be required at the end. And so for this method, this is a query relevant summarization method. So a query is required to score the sentences. So to generate this query, I've calculated the TF IDF scores of all the processed words. And I've selected the top 10 to 12 words with the best TF IDF scores, which can serve as a query. Once the query is generated, the MMR iteration starts by selecting a sentence with the highest cosine similarity with the query and adds it to the summary. And at each iteration, the MMR scores of the remaining sentences are calculated based on this equation, and the sentence with the highest score is added to the summary. And finally, the iteration is terminated when the number of sentences in the final summary is matched with the required number of sentences. For example, it's 4 or 5 sentences. And I've also reordered the sentences so that the original order of the sentences is maintained, which gives a natural flow to the summary. This is an example of the generated summary from a couple of travel blogs on the destination Iceland. And these blogs discuss about what to expect and the suggestions when going to this place. So the highlighted words here are the words which are selected as a query in this summarization. And the first thing to notice is that the stemming of the words has helped in providing a better results. So the words traveling and tours are originally based on the query words travel and tour. And this summarization also has enough information to understand the context and what to expect when for this destination. And however, there are a couple of things to notice here. The first thing is the reference here. So it starts with here, and which can be out of context. Although the reference is mentioned in the second part of the sentence, this might not be the case. And the other thing is that the sentences can be a bit long because these are the original sentences from the blog itself. The next method that I've used is an unsupervised abstractive method. So the main idea of this sentence graph compression is to create a graph of sentences and cluster them into 4 to 5 clusters and compress each cluster to a sentence of the summary. So the first step of this method is to create a graph where the sentences are the vertices and an edge is added between two sentences based on the different criteria. And some of these criteria are mentioned here. So if an event is mentioned in a verb phrase in a sentence and is referred as a noun in the next sentence, this is called a deverbal noun reference. So playing soccer and soccer can be an example. So in this case, an edge is added between them. The next scenario is when there are discourse markers like therefore, however, because, etc. So for this project, I've used a set of 39 discourse markers, which are used to check if there is an edge between two sentences. And another scenario is when two sentences have at least one common entity, like a person or a product. So I've used Python's Spacy module, which has 18 entities to categorize the words for creating edges between the sentences. And the final step is to check if there is a similarity between two sentences. And I've used cosine similarity for this. And I've added an edge if there is a cosine similarity of 0.9 or more. Once the sentence graph is created, the graph is clustered into k clusters, where k is a number of sentences in the desired summary. And the k eigenvectors are extracted from the Laplacian graph. And I've used a k-means algorithm to cluster this into k clusters. The final step is to compress each of these k clusters into a single sentence of the summary. So for each cluster, I've created a word graph by iteratively adding sentences to it. So initially, the first sentence is added. And for each new sentence, for example, let's say the word Monday is present in the first 3 sentences. So for the second and third sentences, this word Monday is mapped to this particular node. And to create a sentence, a path is created from the start and the end nodes. And there are many ways to do this, but in my project, I've used the approximate number of words to get as a parameter to find the path between the two nodes. So I've used the same travel blog articles from the MMR results here, and this is the summary from this method. This summary is more concise than the MMR results and also provides the important information. But however, it also has the same issue of having the reference word in the first sentence, which is out of context. And in some instances, I also found that the summaries can be grammatically incorrect based on the ordering of the words. And as you can see in this sentence. The dataset that I've used for evaluation is the DUC 2004 dataset from NIST. And this dataset has 50 document clusters with an average of 10 documents per cluster. And this dataset also has human evaluated summaries, which are used for the evaluation. So for the evaluation, I used ROSE, which is one of the tools that measures the quality of a summary by comparing it to other ideal summaries. And ROSE is one of the methods which counts the number of common n-grams. An n-gram is a n consecutive set of words in a sentence. So the metrics recall and precision. So the recall compares this count with the total number of n-grams in the reference summary, whereas the precision compares to the number in the model summary. The F1 score is generally used for evaluation, which takes both recall and precision metrics into account. And for this project, I used ROSE1 and ROSE2 for evaluation. ROSE-L is another metric which measures the longest common subsequence between the summary sentence and the reference sentence. And so I've used the F1 score from this metric as well for my evaluation. So these are the evaluation results of the summaries from MMR on the DUC dataset. So the summary length and the parameter lambda has a linear effect on the ROSE scores. I found it particularly interesting because a higher lambda gives a better score. My interpretation is that most of the sentences in this dataset are not redundant, and it is better to use higher lambda to get more query relevant sentences. The smaller the summary, the better the scores. This is because as the length of the sentences increase, the probability of overlap decreases, but it doesn't give much context to have just one sentence in the output summary. So it is ideal to have 4 to 5 sentences in the summary. The optimal query length that I found was to be 12. So if it is higher, the less relevant sentence can be prioritized for the summary. And if it is lower, the query doesn't have much impact on making the decision. The scores for the sentence graph compression are lower than for the MMR results. And the number of words in the summary has a linear effect on the ROSE scores. And as the number of words increase, the summary sentence becomes close to the original sentence and loses the conciseness that was a pro for this method. And also, it is found that the summary length is found to be optimal at 5. But these evaluation metrics only give a limited information on the model performance, as they may vary depending on the documents. And also the humans summaries are also subjective, and this also affects the scores. I'm going to share the demo of the project quickly. So this is the user interface that I've developed for the project. This takes the URLs. So I've selected 2 URLs, which these are 2 news articles which discuss on the current increase in the gas prices. And the user can select the 2 different methods that I've used. And so the text from the documents, these URLs are processed. And this user interface gives the author information, the dates, and the summary based on the method chosen here. So if I click summarize, so it gives all this information and the summary based on the summarizer method. And it also gives the polarity for each article to give user the context of the sentiment of the article. And I'm not going to show the sentence graph compression because it takes a lot of time for the evaluation. Thank you. Any questions, please?
Great, thank you. Next speaker. Okay. Okay, so we're a little bit into question time, but we have time for maybe
I'm sorry.
1 or 2 questions. Any? Either from the remote audience or the in-person audience. Any questions? Okay, I guess I have a question. Sorry if you mentioned this. Is there any pre-processing needed to handle, for example, if you're trying to apply this methodology to, say, a blog post where there may be a lot of misspellings or something? Is it kind of robust to these issues? You have to pre-process the data in any way?
For the 2 methods, for the maximal marginal relevance, I've used a lot of pre-processing because it needs the stemming of the words. But for the sentence graph compression, there is minimal pre-processing required, because since we are creating the word graphs, all the stop words and the actual verb form of the words are required for creating the summary. So I've done minimal pre-processing in the sentence graph compression. But as per your question, if it handles any misspellings and all, I have not added that into account.
Okay, great. Any other questions? Okay, if not, let's thank the speaker again.